Hello friends, and welcome back to Behind Schedule and Over Budget. In our previous pilot episode, we made our introductions, had a lovely cocktail hour, and I gave out the first impression rose. More importantly though, I introduced our first project, which is our Cyberdeck build. And while I gave a high-level overview of what we're going to do, I didn't go into much detail beyond that. So in this, our second episode, I'd like to make a nice deep dive into what this Cyberdeck project is going to be, and kind of set the stage for what the next few episodes will be. So, without further ado, let's hop right in and get to it. So, what is our Cyberdeck going to be? Well, as I pointed out in the first episode, it is a Raspberry Pi powered DIY laptop build. The case will be 3D printed, and there'll be a bunch of other parts that will go in there to make it a true blue laptop. So beyond that, though, there's a few things we should look at before that. I know I brought out in the first episode my Tandy 1400 LT and showed it off as inspiration for this build. And while I do think the Tandy is a great computer, and I think it's a very representative machine of an 80s laptop, there's another machine I came across during my research that I decided I wanted to be the design inspiration for this build. And if anyone's out there is a 80s computer enthusiast, you probably have heard of this machine and have a good appreciation of it, as I do now. So what is that machine, and why are we going to be using it as our inspiration? Well, first of all, the machine is the Grid Compass. So, just looking at it from this image, we can see that it's a pretty sleek machine. Again, unlike a lot of the machines or its peers of the day, it's pretty thin. It's got some pretty clean, almost modern stylings to it. And overall, it's a good-looking machine. Again, I really appreciate it because you could tell it's an 80s laptop. It's got that bulk. It's got that angularity to it. But at the same time, it does not look, it doesn't look ridiculous. It has a good mixture of modern and retro stylings. And surprisingly, this is an old computer. It was released in 1982. Its peers at the time, if you look up some of them, do not look as clean and sleek as this. But as we'll see in the upcoming slides, there's a reason it is allowed, or there's a reason it was able to hit this level of polish at that time. So we'll get to that in a minute. But yeah, I think the Grid is an excellent looking computer. It has a lot of great history to it that we'll see. So I think it's worth paying an homage to. And overall, from my experience, it is. As I've already gotten a lot of this design done at the time of filming, it was a very fun design to try to design around. So you can see it has a pretty boxy rectangular casework to it, which is, made things a little easier on me trying to design these parts for 3D printing. Some of the other designs I looked at, they either had slopes to them or angles or strange things, and it just would have made printing them and designing around them a lot harder. So I think you get the complete package with the Grid Compass. You get a computer that is, kind of well known, has famous for several reasons. So what worth paying homage to. That's also good looking, and lends you a lot of favors as you try to design to it. So let's go on a little bit and talk about what the Grid Compass was. So it was released in 1982. So as I said, it's an old machine. As far as laptops go, as far as portable computers go, it's very early in the game. As far as its specs go, it had an Intel 8086 processor, a 320 by 240 electroluminescent display, and as you can see in the image to the right, it was an amber display, which looked great, especially if you look up real pictures of it. This is actually what we're looking at, is some CAD. They came from Shapeways, if I'm not mistaken, that I purchased from, which I really appreciate because it allows me to turn this design around as if I had one in front of me, and we get great pictures out of it. Beyond that, it had 256K of DRAM and 384K of non-volatile magnetic bubble memory. The whole thing was housed in a die-cast magnesium alloy case. And again, as I pointed out, it was able to hit all of these great features at the time for one reason, and that is that it was expensive. It cost $8,150 in 1982, which comes to $22,000 in today's money, which is more than what my car costs. So that is a price tag that only the U.S. government could love. Apparently the government was a pretty emphatic buyer of this machine, and apparently one of them flew on the space shuttle. So another reason it's famous. One other thing of note is that, I guess another thing a little corner they had to cut in order to make it what it was that there's no battery in the Grid Compass. So it's not actually a portable machine. It can be moved from place to place easily, so it's portable in that regard, but it cannot be used away from wall power. I don't knock it too much for that. Again, I think overall the stylings that it managed to hit for the time are really great, and its design is, pretty impressive for 1982. And again, looks wise, I think it's the perfect kind of computer to draw inspiration from. So, again, what do we like about the Grid Compass? Its sleek look. It has a rounded rectangular profile, which again is a good mixture of. It really, if we look at it from this angle, it's stark. It's got a great feel to it. It's angular, but it's also sleek. And again, I think it is a perfect mix of retro 80s styling and modern sensibilities. And I think if I'm going to design a computer like this, I like to follow along with something like this. As much as I want to pay homage to 80s machines, there's no sense making it big and bulky. Some people have already, kind of treaded those or gone down that road before, so I'd like to try a different approach here. The other thing I think is worth pointing out is that it has the extended back, something I pointed out on the Tandy machine that I brought out in episode 1. I like it from a looks standpoint. Again, I think it screams 1980s. It screams that there's a lot of things going on in this computer. And it also helps from a design standpoint because much like the challenges that designers in the 80s probably faced, is that we have a lot of big components we need to fit into this computer, things that we can't package underneath of the keyboard like a modern laptop would do. So we're going to have a big, a large caboose on our laptop as well. So yeah, it's something worth emulating. Beyond that, the way the parts break up in this case, as you can see in this picture here, there's a base part, display shell above. The display goes into a rear shell in between the display and the rear cap. And yeah, I think as I designed this, I actually kind of kept to those part breaks as well, and it really made the design kind of flow pretty well. Some things we won't be following along with is the kickstand we see on the picture here. I think that's a wild concept for this computer, but it just so happened that there just wasn't room for that in the current design. And going back, maybe if we look at the picture from the front real quick, there'll be less bezel on the display. So we'll see that in a minute as we get to the real machine. One thing I do like is that the bottom of the case, or the bottom of the display shell, angles a little bit in order to keep it aligned with the pivot points when the computer is fully opened. I think that is a great little, let's see if you can see my mouse here. You can see it right here. As this screen is fully opened, the bottom of the display shell angles down a little bit and gives you a good flat plane going across here. I think it's a very neat little detail and shows that they really put a lot of thought into the design of this machine. So that's something I want to kind of steal for my design. So yeah, that is what to like about the Grid Compass. So the next thing we're going to get into is our machine. And before I get into that, I just want to point out that, again, because this video is shot a little out of sequence, I've already built up this machine. I've already gotten a preliminary build of it done, and I was able to learn a few lessons that I did not know at the time of making the slideshow. So a few things here will be crossed out, and I will speak to that as we go, just to highlight a few changes that will be done to the design that aren't really represented in this slideshow. So without further ado, what I hope is the next slide is our machine, the Grizz Sextant. So here it is, ta-da. First things first, we should probably talk about the name. Again, it's silly. Grizz, because I think that word sounds funny, and it looks a lot like the word grid, and sextant because of a few reasons. And much like a compass, a sextant is another navigational tool. It also has the same number of letters in total, Grizz and sextant, and it has the word sex in it, which is funny. We're not going for highbrow humor here. So yeah, not a lot of thought put into this, just a silly name to give it, something to tie it to the computer that inspired it, while also giving it its own silly makeup. So yeah, here it is, and you can see in some cases it looks a lot like the Grid, and in other cases it doesn't. Again, I went with a bit of a different color scheme here, something probably closer to a Commodore 64 than the Grid we looked at previously. I really dig this beige and black color combo, also a color combo done on the Tandy 1400 from the first episode. The keyboard is a 5x12 ortholinear keyboard. The display is a 7-inch HDMI display. And yeah, again, the part breakups were kept very similar to the way the Grid worked. As you can see, we kept that little angle at the bottom of the display frame. The back isn't as deep as the Grid, and that was for several reasons. That is to keep the total height at least as this thing prints, this base part here will be printed with this face down. So we wanted to keep the height of this below 8 inches. So that's where this kind of tops out at. And again, we didn't need all of that height. We didn't need all of that depth. So we can keep this thing to a more reasonable set of dimensions. Other than that, you can kind of see that the way that the bezel on the frame works is a little bit different than how it works on the grid. Mainly because this, if we go through these parts, maybe in CAD in the future, we'll see that it allows this beige part up here to print a lot easier than it would if we tried to build that big bezel into it. Essentially, this just forms kind of a C-shaped profile with a cap at the end of it, and this face up here actually prints down. And again, pretty easy to print. So yeah, here is our machine, is the Grizz Sextant. Beyond that, I think we're about 9.5 inches wide, close to 10 inches deep, and 2 inches thick. If I go through the CAD in the future again, we'll see that there's a lot, or I took a lot of pains here to try to make the CAD, or the design, space efficient. Pack everything in here as tight as possible while still leaving enough room to actually build the damn thing. So one of the main reasons for that was, besides for keeping it small, I could have lived with it being a little bit larger, but one very important thing was I wanted to keep these parts that we see here, so especially the largest parts, the base, the display shell, and the rear cap, which is actually one of the toughest parts to fit on a printer. I wanted to keep these all or at least make these all able to fit on an 8x8 inch 3D printer platform. We do that diagonally by printing them across the corners of the platform. And again, height-wise, we're about maxed out as high as we can go because the rear shell will barely fit at that point. I actually had to increase the radius on the corners in order to make it fit on my machine. But I think if it can fit on my machine, it can most likely fit on your machine. My machine is an Anycubic Prusa i3, or i3 Mega or something like that. It's a $300 printer, no special bells and whistles to it. I believe that a Prusa i3 Mark III has a larger print or build platform. So again, if you have one of those, you should be fine. Something like the Ender might be a little bit smaller. I'm not sure. One caveat I would say is that, if you ever consider taking on this build in the future, once I release the parts, make sure you can print this stuff first. Maybe make sure you've printed the parts first before you put any other money into this design or into this build. So yeah, here's the front view of our machine. And here it is closed. So yeah, a couple other features to look at here. Again, I like the way the lid comes closed. I wanted to put a little bit of aesthetic flair onto here, on the outside of it. So I got this little grill work to work in the CAD as it turns around the corner of the display shell. And one other thing we see here is a little logo that goes on the top of this. This was actually designed by a graphic designer I know, and she did an amazing job. And we also have an alternate version of this logo that looks a little bit more like the Grid Systems logo. This one here was designed to pay homage to the Commodore 64 logo. Not a copy of it, but something to kind of go with that rainbow and that kind of look to it. So yeah, I love the way these came out. I think they look great. If we look at the CAD, there is a reason this logo exists, in case you have any doubts about the looks of it. There's actually 4 screws underneath of this thing that hold this display shell to the frame underneath of it. It's the only place I can think of to put those screws at, and they looked very unsightly. I actually tried to design this as best I could to keep any visible hardware off of the outside of this. If you turn it over and look on the bottom, there's a ton of hardware, but I think that's fine. Something can have hardware on the bottom of it. The bottom of a device is not supposed to be looked at. It's the face that sits on the table. But the top, the front, the sides, the back, I tried to keep those as clean as possible. And eventually I just ran to a point where I could not think of a better way to mount this display shell to the frame underneath of it in a way that's easily 3D printable and hid all the hardware. So as a way to hide my sins, I got this lovely logo made up, and all in all, I think the design is better off because of it. But yep, this is what it looks like closed. And yep, a nice view of the back of it, and also we'll go over some features in a second. But just looking at the back, again, the rear shell, so the rear cap of this is essentially its height is the entire height of the unit, which is one of the things that makes it the most difficult to print, because it needs to fit with this face down on the print bed, and it needs to fit diagonally. So it's a little bit of a tight fit, but again, I've gotten one of these to print on my home machine, so I'm pretty sure you'll be able to as well. Again, you can see the Raspberry Pi in there, the power input, power switch, and a few other things. You can see where some of the visible screws are on the rear here. I think these are okay. I actually love the way these screws look. One thing I went for was a black oxide screws in order to go with kind of the color scheme here. I think they fit great, and they're pretty cheap. Actually cheaper than stainless steel screws in many cases. So as far as that goes, it works out pretty well. As for the features, so this is built around a Raspberry Pi, essentially Model B. You can use any Model B you have right now. I say a Pi 3. I have one on hand. I've tested it with a in-process power supply. We'll talk about that in a second, and it works. And I actually have my current build built up with an original Model B, which works with the current power supply. Again, we'll talk about that in a second. But again, just the Model B. It's built to fit the Model B. Beyond that, we have a 7-inch 1024 by 600 display, so a high-def display. We have a 5x12 JJ50 mechanical keyboard with an ortholinear layout. We have headphone audio output. So again, not even in my current build, kind of just skipped past it because I wanted to be able to get this thing put together and ignore some of the wiring. Kind of figured, kind of put sound low on the list of priorities. So in the future build, we'll get that worked out. And one thing, oops, sorry about that. And one thing is a friction hinge for the display. Something I built in that we'll go over in the future is we have a little hinge here that actually, you know, it's not a free floating hinge. There's actually some friction to it so that this display won't slam shut in case you knock the computer or something. So the one feature I skipped over was the battery. As designed, the unit was supposed to have a 6600 milliamp hour battery, 3.7 volt lithium ion battery, whose voltage is stepped up to 5 volt by the Adafruit Power Boost 1000. It works, it just doesn't work as well as I wanted it to. And that's basically my goof. I've used these in projects before. They were a little lean on power as it was back in the day, and that was before I was using a high-def 7-inch display. And it seems that I'm maxing out how much current capacity I can get out of a Power Boost. So that becomes a bit of a problem. I've tried to use this with the Raspberry Pi 3, and I'm getting brownouts on how much current I'm trying to draw between the two of them, which is why I'm using an original Model B at the moment. So as it stands currently, I have this thing built up, and I'm working out a new solution that uses a power bank, you know, like a phone recharger. I've tested it out. I've tested it with a Raspberry Pi 3. It works much better. I need to rework the CAD, and I also need to rework some of the wiring of the system in order to make it all work together. So that's why we're just kind of consider the power or the power in the system to be in process. Another important bit I want to work out here is that as it stands, if you try to power this off the wall, technically what you're doing is power or recharging the battery. And if the battery's dead, you can't use the system, which is something I don't really like. I want to be able for this thing to be powered off the wall indefinitely, kind of circumvent the battery instead of charging it. So that's something else I'm working out here. I think instead of getting into more detail, we'll have a video about that in the future. Just know that the power as is works, but not as well as I'd like it to. And as a follow-on project to this, I've decided to take on an effort to redesign the way the power works here and make it better. All right. So here's some side-by-side comparisons of the two machines. And again, you can see there's a lot of similarities and a lot of differences. One thing about the Grizz shown on the right is that the keyboard takes up a lot more space down in the keyboard area, mainly because, again, there's an interplay between how big we can make this thing or how small we should make this thing in order to fit it on a 3D printer versus how big the parts are. So essentially, to fit on the 3D printer, we have shrank the width of this design as close as we possibly can to the keyboard, which means, you know, we just don't have this nice bezel that the Grid has. It's fine. I think it looks okay. It looks a little awkward, but overall it looks fine. Especially in the real build, it looks great. Beyond that, again, the way the bezel works over here, you can tell, I think, in the Grid that this front face is a different part than the rear cap. It's kind of how this works, but I made some trade-offs in order to make this much more 3D printable. So we get this kind of awkward edge sticking out here. Not perfect, but, you know, just some corners that we had to cut here, or some, let's just call them cut corners we needed to do in order to make this thing 3D print well. And again, overall, I don't hate it. I think it looks okay. And yeah, other than that, we know that we can see that its proportions are a little different. The back isn't as deep as the Grid. Obviously, the color is different. If you look up the Grid Compass online, you can actually find a version of the Grid that was done with a beige color scheme, with a black rear cap, which is actually one of the big reasons I took this color scheme as well, because it looks excellent in that color scheme. I don't know if it was powder coated or anodized to look that color, but man, it looks great. That's why I have this, one of the reasons why I have this beige look. And yeah, another thing, we don't have these or latches on the that the Grid has. Just something that was almost going to be impossible to fit with how tight we were to the keyboard as is. Was one of the things that the friction hinge is there to replace. It gives you a little bit of feedback as you try to open and close the display, and it's not optimal. I would have loved for them there to have been a latch, but again, like I said, just wasn't. There wasn't enough space to fit it. B, it would have made 3D printing some of these parts very awkward. And C, I was just getting sick of the CAD after a while and wanted to get this thing onto my 3D printer. Maybe we add it as a nice to have in the future. So a comparison of the back, yep, again, way shallower. So this has more of a rectangular profile if you look at it from the top, whereas the Grizz is actually almost close to a square, which is nice. I think it looks pretty cool. And yeah, a lot of similarities looking from the back, actually. Similar rear cap, similar part breakups. We don't have this break in between the hinge covers on the Grid. It's actually one seamless part. I like the way that works in this. And obviously, there's some aesthetic flair here that was added to kind of throw in some other computers into the look. I think this kind of lifts from the Commodore 64. So, it's not a one-to-one representation of the Grid Compass. It's more of a inspired by the Grid Compass with hints of other computers thrown in as well. This is supposed to be an homage to all 80s computing, not just one 80s computer. It just so happens that there was one computer out there that was really good to follow along with. All right. So again, this is, for me personally, and if you're going to follow along with this, it's worth asking, what do we want from this project? And first and foremost is that we want a functional portable computer. Again, I think in the past I've tried building something like this, and I wanted it less as a retro 80s thing, and more of I want a Raspberry Pi computer that I can sit on my lap. Something I don't have to plug into the TV and plug in all the peripherals into. I wanted something that was easy to work with, something that I could learn with and toy with. And that's kind of the other half of this build. Besides for being a 80s homage, it also needs to be a functional portable computer. And personally, in my opinion, I think it should be a functional portable computer first, and an homage to 80s computing second. Because, as we'll see in a future video, hopefully, it's not cheap. It looks like the bill of material is coming in at about $350. So if you're going to shell out money like that, I really think you deserve to get something good for the price you pay. Something that's good to use, something that you might want to take out on a daily basis and get some actual functional use out of. And then, as an add-on, hopefully it should look cool, it should feel great to use, have a unique look, something that you're proud to take out and show people. So yeah, beyond that, we want a great feel. And that's where our mechanical keyboard comes in. It's just something you can't get in a modern keyboard, something that's, or not a modern keyboard, a modern computer, a modern laptop, something that sets it apart. Good size, not too small, not too large, good ergonomics. It should feel well sitting on your lap. It should feel well to type on. So I think we're close enough on that. We did as well as we could with the parts we had and the manufacturing processes we could work with. And then a unique look. We go with that 80s, that AT aesthetic. There's plenty of typos peppered throughout this presentation. But yep, we wanted a unique look. We wanted an 80s aesthetic here, and a mixture of 80s, retro and modern aesthetic. So a very unique looking computer. We wanted it to be easy to build. This is something very important to me. I am lazy. I am lazy by nature, so I don't want to do extra work if I don't have to. So when I'm designing something, I want to try to not cut corners, but I want to try to make things as simple as possible, which in some ways puts more work on me. But in the end, when it goes comes time to build something, you wind up with a setup that doesn't require you to build everything from the ground up. So, what I'm trying to say here is the design as finished is easy to build. I have a video of the build I'll post in the future that, it actually comes together once you have all the parts in front of you in less than an hour, which is great. I'm pleasantly surprised by that. I'm happy the way that came out. So, once you have all your parts on hand, once you have some of the slight modifications ready to go, 3D printed parts done and prepped, you can sit down and in about 2 hours, for the first time, get all these parts together. And it feels great to build. So one way we go about this is just going with limited custom parts. We're not going to be building our own computers here. We're not going to be building our own displays. You have to put the keyboard together, and there's a lot of work that goes into that, but it's very straightforward. It's just a lot of repetition. and easy 3D printing. I use that in quotes because from my experience, 3D printing any large part is not easy, but at the very least, I've tried to design these parts so that there's minimal support material, and I've also tried to work out some instructions that I can provide in order to take some of the pain away from 3D printing these. Not worth getting too much into, but at this size, these parts tend to warp a lot as they print, and it's just I've figured out some ways to mitigate that, but you're never going to get around it 100%. So just try to take as much pain out of the 3D printing as possible. And finally, we have an acceptable price. Again, in quotes. There's a lower limit to how cheap some of these parts can get, and that kind of sets a lower limit to this unit. I can cut corners, or I can pinch pennies here and there to try to make this a little bit cheaper. Maybe even leave options where you can decide whether you want to save a little bit of money or save a little bit of time. But at the end of the day, I think the base set of parts that goes into this machine, especially this JJ50 keyboard, which costs almost $100 on its own, the base set of parts that go into this machine are almost $250. The extra $100 comes from some cables, some hardware, some things here and there that you can circumvent in some small areas, but overall you're kind of stuck at that price range. I wish it could be cheaper, but that's just the reality of it. So let's take a deeper dive into each of these points and talk to them a little bit more. So, again, how did we get there? So, functional computer, first point. Raspberry Pi based. So, I have not, I want to say a lot of experience, but I've definitely built Raspberry Pi projects before. I'm very impressed because they have a strong existing ecosystem. They're easy to pick up and learn with. They have all the necessary I/O ready to go, and they're pretty straightforward to build around. So, I know there's other computers out there. Some of them might have advantages in and of themselves, but I really like the ecosystem around the Raspberry Pi. I think it's pretty easy to get up and go with. I think it's it's my kind of speed, and I think if you're going to be building this, it might be your speed as well. So it's great to work with. That's why we picked the Raspberry Pi. Again, let's skip the battery for now. Save it for another video. All you need to know is that I'm working to design a lithium-ion battery pack into this, more of a power bank, something off the shelf, so that we can get optional wall power or battery power, with a few caveats here and there. But in the end, there's still a design in here that's going to offer actual battery power to make this a portable machine. Just is going to require a little bit of extra work. And keyboard. So this is the largest mechanical keyboard capable of fitting in this design. That is, as it boils down to it, I think it's considered a 50% keyboard. There are 60% keyboards out there as well. The 60% keyboards are a little more common and easier to source and come across, but they would have made this thing so wide that it wouldn't fit on a normal 3D printer anymore, and also without at least breaking the parts apart, which I really didn't like the idea of. And plus, it would have made the 7-inch display seem kind of lost in the design. So this 5x12 ortholinear keyboard layout is the largest keyboard layout we can fit in this design. That's one way of looking at it. It's the smallest keyboard we can get while still being functional. So that's why it was picked. Again, there are some cuts you have to make here. You have to use different layers on the keyboard to get at certain keys. So, a little bit of pain there. But overall, it's a great keyboard. It's great to type on. I've had a lot of fun using it so far, and it fits this design pretty well. All right, so next up, great feel. Again, mechanical keyboard, one of the most important things. Great fun to type on. It's a unique feature that sets us apart from an off-the-shelf laptop. And again, there's just some drawbacks that come from it being or having less keys than a normal keyboard, but they're pretty easy to work around. Good size. Again, we're about 9 inches square across the width and depth, and about 2 inches deep. So we're about the size of a netbook here. Not as thin as a netbook, but footprint size pretty well. Again, as far as the design is concerned, tried to waste as little space as possible in here. And then good ergonomics. It's not too heavy, good weight distribution. The keyboard helps balance it out from front to back. It's a simple shape, it's easy to carry, and it has that friction hinge in there to stop the display from crashing down. So I think ergonomics-wise, I have the genuine article in front of me now, and I think it feels pretty nice. The way the 3D printed parts come together feel nice and sturdy. They all tie together into one cohesive unit. So it doesn't feel like it's going to break apart on you. You really actually, it feels hefty. It feels like you could really beat the crap out of someone with it on the street if you wanted to. So yeah, it just feels like a nice solid design, something that just feels real when you hold it in your hands. And then the unique look. So we go for that 80s aesthetic. But beyond that, we're going for a blend of old and new, using the grid compass as our design inspiration. It's sleek and simple. And also a little bulky. So it's got that 80s bulk, but it has a nice modern sleek to it. And then we throw in a little bit of 80s flair to a little bit of 80 flair. You know, there's 80 flares inside of this thing, so don't put any matches near it. No, we have a little bit of 80s flair inside of this that, just kind of helps give it a nice look. You know, in the beginning, I wasn't considering putting something like this on, but I decided that it looked a little plain without it. I could even potentially consider offering a version of this that doesn't have the grill work if that's not your speed. But yeah, I think, I like the way it looks. I like the way it wraps around. I like the proportions of it and such. I think it looks neat. So yeah, at the end of the day, it should hopefully be a very cool looking little machine. Hopefully something that if you go through all the trouble of printing and buying, printing, soldering, assembling, something I hope you're proud to take out and show to people, and just get weird looks from people. And then easy to build. This is an important one. Again, it's just a design philosophy of mine, and in that, yes, we could do a lot of extra work here to make a lot of things happen. I also am a little worried that the future battery solution is going to kind of run into some issues with this point here. But for the time being, we're looking for a straightforward design. So a low number of parts and hardware, a limited modification of those parts, simple assembly, and select components with robust ecosystems. So the low number of parts, limited modification, just means that as far as hardware is concerned, I try to design around 3 unique pieces of hardware. So you don't have to buy 100 different screws. Just buy a couple different bags of screws, and that's it. Limited modification of parts. Again, where possible, I don't want you to have to cut a board in half and resolder a billion things back together. I think an earlier version of this design had a lot of that involved, and I just wasn't happy with it. So I did a lot of deep changes in order to make it as easy to build as possible. Simple assembly. Again, if we look through the build video in the future, I think we hit a good mark there. When it comes time to actually build this, it clicks together pretty well. And then again, selecting components with robust ecosystems. One issue I could talk to right now is that the keyboard here, it uses the QMK. It runs on a QMK software to work as a keyboard. It just so happens that there were some issues getting this keyboard to work with a Raspberry Pi that nearly tanked this entire project. Luckily, in the end, I was able to find out what was wrong and fix it. But again, it's kind of just speaks to the pitfalls of not going with something with a robust ecosystem. It just so happened that there were very few people that were trying to use a JJ50 keyboard with a Raspberry Pi, and that made it really difficult for me to figure out how to fix this. Luckily, I did, and then that can be part of the documentation in the future. Again, limited custom parts, stick to off-the-shelf parts where possible, and keep any modifications as simple as possible. I think as far as there's a minimal amount of soldering at the moment, and as far as the off-the-shelf parts, you really don't need to play with them that much. You got to tap a few holes here and there, and you're ready to go. And then again, easy 3D printing, easy in quotes. We can't avoid how large these parts are. And I took pains to make sure that these parts can be printed in single pieces. I think that was very important to me. I just don't want there to be a giant split down the middle of this part. If you find you need to do that, and you want to split these parts on your own and glue them together, there's nothing wrong with that. But I really thought some of the magic of this design would be, hey, let's make it so that you can print these all in one piece. So no unsightly splits down the middle, no glue marks or anything like that. Save you a lot of trouble assembling it, and just push some of that trouble up front, getting your print bed leveled and getting these gargantuan parts to actually start. These are all sized so they can fit on an 8x8 3D printer. Again, they fit on my 8x8 3D printer. My machine is nothing special. It is a run-of-the-mill 3D printer, and it was able to print essentially all of these parts. I had a friend do some of the printing for me on his Prusa i3. They came out great on there. They came out great on my Anycubic. Hard to tell actually the difference between the two of them. So hopefully if my machine works, your machine works. Like I said, you're best off printing these parts first before you commit to buying anything else. Make sure you have a set of parts in hand before you put any more cash into this. And these, like I said, these parts are a close fit, but they should work if they're rotated 45 degrees on the build bed. So if you have a square build bed, you're going to put these diagonal across. Another thing I've learned while printing these parts that I can mention real quick is that Warping becomes a big issue with these parts. It's almost just unavoidable. These are big parts. They have a thin aspect ratio, so I think they cool unevenly. Even in PLA, inside of an enclosure that I have in my basement and my printer inside of, with the cooling fan off, I still got some warping. I think at the end of the day, luckily the tolerances on all these parts are pretty loose, so they all still fit together in the end. And I'm trying to make a few modifications here and there that should hopefully allow these parts to fit together even if they warp. But again, your mileage is going to vary. It's going to be a little bit of an effort to get all these parts to fit together correctly. But again, hopefully they work out for you if you try to print this, and yeah, hopefully I made them easy enough. And the acceptable price. Avoid high-end components if possible, and that kind of means using some no-name brands in certain cases. Find the best component deals. I hunted around, try the bundle thing, so maybe you make one big Amazon order, one big DigiKey order, keep your one big Adafruit order, and keep your shipping costs down, and keep the hardware count low. One bag of screws from McMaster could cost you $10, so if there were 5-10 different parts in here, that's $100 right there. We don't want to have to spend $10 to get a bag of 100 screws, of which we're only going to use 2. So a little bit of pain was taken there to keep the hardware count low, which probably helped shave $30 or $40 off the BOM cost. And again, like I said, there's just a lower limit here. A Raspberry Pi 3 costs $30 or $40. The display costs $50. The keyboard costs $100. A battery is going to cost you $30 or $40. That's almost $250 right there, plus a few other things. And that's the core components of this computer. Even before we start getting any special tools, any other special parts you might need, just to get the core of this computer together is going to cost you $200+. So we can only do so much as far as price goes. Like I said, if you're the kind of person that's going to build this, I don't think price is too much of a concern for you. I wouldn't want you to spend $1,000 on something like this. So I tried my best to keep it as low as possible so that hopefully you get good bang for your buck. You get a good computer out of this for $300 to $400. And yeah, that wraps up this video. So up next, I already have a few build videos shot. I'll be working on uploading those. I'm very excited to share those. We can walk through it and see this build come together. Past that, like I said, there are some issues that I found with the current design, specifically around the power supply that I'm working through. So I'd really like to work through those issues first, get the design updated, and make sure I'm happy with it before I release any parts online. Maybe I can be tempted to not do that, but I really would, if I'm going to put a design out there, I'd like it to be pretty airtight as possible. Yep, I think we'll have a few more videos in the future that'll go into some of the issues, some of the lessons learned from this build and where we'll be going in the future. So I hope you stick around for that, and yep, excited to see what the future has in store. Thanks for watching.